Alright, man. Quick, exercise 9B. Yeah. Alright, cool. Question 1A. Yeah. So we just need to differentiate this situation here. Yeah. And to differentiate that, basically, we're gonna have is y equals 4e 7x. And so to differentiate this, basically, we're gonna need to use chain rule here. So effectively, what happens here is the 7 moves down. So the 7 here moves down there. So that becomes 7 times 4, which is 28. And then e to power of, and then the 7x stays the same. So whatever's in the function stays the same. Yeah. So just 28 e to power 7x here. Column B. Y is equal to 3 to the power of x here. So we've got 3 to the power of x here. And then to do dy over dx, all you need to do here is just it's gonna become basically you write the same thing, so 3 to the power of x here, but then it's gonna be ln of whatever this base number is. So ln of 3 in this case here. You get it. Alright, cool. Quick part C here. Part C we got so we got 1 over 2 to the power of x here. Now again, it's same as last time here. So if you've got anything like a to the power of kx here, it's going to differentiate into dy over dx here. It's going to become a to the power of kx. You just write a to the power of kx and ln whatever the base number is there. Yeah. So effectively here, you can already think what it's going to be here. It's just going to be so just write this whole thing again. So 1 over 2 to the power of x here, ln of 1 over 2. So that's the answer here for dy over dx. Alright, so question D here. Alright, question D, like, obviously here we've got y is equal to ln 5x here. And now, listen, I'm going to explain this one time here, and I'm not going to explain it again. This ln 5x here, it just differentiates into 1 over x. And the reason for that is because ln 5x here is technically ln 5 plus ln x here. Because of the rules of logs here, when you have a ln plus ln or any log with the same base, because remember ln is just log with base e here, and you add it together, that means that you can times them together in that way, yeah? So therefore I can split into that and now deep it, fam. The differentiation of ln 5, that's just a constant, bro. That's just a number, so it's going to be 0. And the differentiation of ln x is 1 over x, which is 0 plus 1 over x, which is just 1 over x. So ln of any like number with x here is always just 1 over x. It's not 1 over 5x or 1 over 2x, it's just 1 over x here. Alright, so question E. What are we saying here? Okay, cool. So we've got 4. Y is equal to 4. 1 over 3 bracket x here. So again, I told you the rule here. Yeah? Whenever you've got a situation like that, yeah, what you want to do is you basically want to just put 4 open bracket 1 over 3 to power of x here, and then ln whatever the base is here. The base here is 1 over 3. Yeah, it's not 4 times 1 over 3 because this 4 is separate. It's like imagine like this is sine x here, like sine 1 over 3x or something. Yeah, the 4 outside is separate in it. So when you differentiate it, it just stays on the front. You get me? It's like 2 sine x differentiated is 2 cos x. You get me? It's like that. Okay, so for question F. Okay, so we've got y is equal to ln 2x cubed here. Okay, calm. Now, in this situation here, for those of you that have spotted it already, yeah, the ones that are smart, you can clock this straight away. The ones that are not so smart, yeah, obviously you need to do this. So of course we can break this up again into ln2 plus ln x cubed, yeah. And the reason for that is obviously again because like that's the laws of logs, yeah. But if you have two things times together, I can break it up into that plus that, yeah. And now if I differentiate ln2, yeah, that's just gonna be what, bro? Furthermore, I can actually simplify this further. Yeah, if you due to the rules of logs, if you've got a power on the ln here, you can bring that down. So I can put 3 ln x here, and now with that information here, I can therefore say that differentiation of ln 2 is going to be what? Is going to be nothing here because that's just a constant here, and differentiation of 3 ln x differentiated is 1 over x. So 1 over x times 3 will become 3 over x because remember 3 times ln is like 3 times 3 ln is like 3 times ln, yeah? So if ln differentiated is 1 over x, 3 times 1 over x is 3 over x. So you just level 3 over x in the end result. You see that, yeah? The ones that you can clock straight away anyway is that, yeah, there you go. Okay, cool. Alright, question G, yeah? Alright, question G. Question G is saying y is equal to e to the power 3x minus e to the power minus 3x here. And I want to do dy over dx. So again, a very simple situation. You bring the whatever the number is next to the thing down. So 3 down here, e, and the thing inside stays the same here because the differentiation of ex is just ex here. So safe. And then minus 3, bring that down. Minus 3 times minus negative sign here is positive here. So that's positive 3 e to the power minus 3x. Again, what's inside the function, so what's inside of e stays the same. By the way, for e, the function is the power, yeah? So on your calculator, it will say e to the power of a box. That box means that's the input. That's the function that you're putting into it, yeah? So when I say function, that's what I'm referring to. Okay, cool. Same way how, like, for sine, the box is technically here, like on the x. You get me? ln is technically here. You get me? So if I put something into ln, it's there. Put something into e, it's here. You get me? Alright, cool. Alright, question H. Okay, so we got this here. So what you want to do is expand the top here. Use a squared plus 2ab plus b squared, yeah? So a squared, this is a, this is b if you don't know. Okay, so 1 squared is 1, yeah? 2ab, so 1 times e to the power of x, e to the power of x times 2 is 2e to the power of x, yeah? So we got that, and then e to the power of x squared, yeah, is just e to the power of x squared. But if you don't know, yeah, with these rules, yeah, you can, when you times these together, you can actually put them together. So it's e to the power of 2x, yeah, because of the indices rules, yeah? If there's a bracket, it's equal to timesing, yeah? Same way how x to the power of 2 squared is equal to x to the power of 4, yeah? Because you just times the two together. So there's 2x, yeah? And all of that is over e to the power of x. And I can simplify that further to make it easier. 1 over e to the power of x is just going to be e to the power of minus x here. Because if you know, you can write like e to the power of x here. Like, for example, what I mean, I'm not explaining this properly, but like x to the power of minus 1 here is 1 over x. So 1 over e to the power of x is just e to the power of minus x here. So just negative indices makes it 1 over here. Okay, so if 2e to the power x over that is going to become just 2. So plus 2. And then e to the power of 2x divided by e to the power of x, you're going to, since you're dividing 2 e to the power of x's here, you're going to have to take away the indices. So 2x minus x is just x. So we're left with just e to the power of x here. Or you can see that as e to the power, e to x squared here, divided by e to x. Yeah, so if that was x squared divided by x, we would be left with x, yeah? Same way how, because e to the power of x squared is over e to the power of x, it's going to be e to the power of x left over, yeah? And so that's the situation there. Now we're going to differentiate that. I'll obviously bring negative down. So we've got negative there, and then the power remains the same, yeah? 2 fucks off completely, because obviously we've got the situation there. Obviously, that's going to make 0 as a constant, yeah? And e to the power of x differentiates into e to the power of x here, so it stays like that. Alright, safe. Alright, question 2, yeah? Question 2a. Okay, so question 2a, yeah? What's question 2a saying? Question 2a is saying, find f dash x given that whatever, yeah? So we've got f of x is equal to 3 to the power of 4x here. And we need to differentiate that. So again, remember, yeah? Remember the rule here, bro. We write the same thing again. So we write the same shit, so 3 to the power of 4x. And then we do ln of the base here. The base here is 3. But, there's a little bit of a difference here. Because I've got the 4 here, you need to also add the 4 there. You get me? Yeah, so basically, I'll write out properly here. So f dash x equal to that, yeah? So if f dash x is in that kind of form, yeah, f dash x will be equal to a kx. So that's what this thing here, that's a kx. And then k ln a, okay? So whatever the number is next to the x, the ones we were dealing before, yeah, they didn't have a number next to the x. So that's why it was okay to assume certain things. But now it has that, yeah, so we can't do that. Okay, cool. Question B. Okay, question B, yeah. Question B says y f of x or y is equal to 3 over 2 power of 2x here. So again, so we write the same one down there. So dy over dx is equal to the same thing. So 3 over 2 power of 2x. But then again, k ln a, yeah. So the thing next to the power, so 2 ln, and then the base, which is 3 over 2. You get, calm. Alright, part C. We've got y is equal to 2 to the power of 4x plus 4 power of 2x here. Okay, dy over dx here is easy here. Here. All we need to do for dy over dx is obviously just do a couple of situations in it. So obviously we keep this the same. So again, 2 to the power of 4x, and then it's going to be k ln a, yeah. So k is 4, so 4 ln 2, yeah. So the thing is the power ln the base here. Plus again here we're gonna keep the same thing the same. So 4 to the power of 2x here, and again k ln a, yeah. So 2 ln 4, you get it. Okay, cool. Alright, see. Okay, nice. Alright, question D, yeah. Question D is saying 2 to the power of something, okay, plus 8 to the power of x here over 4 to the power of 2x here. Alright, cool. So obviously, yeah, whenever you see a situation like this here, date straight away what you need to do. You need to convert everything to powers of 2, yeah. So because we got a 2 there base, this is obviously 2 squared. My bad, I'm trying shit. This is 2 cubed, yeah, and this is 2 squared. So obviously because of that, we can clock straight away that this is gonna become 2 to the power of 7x plus 2 cubed power of x over 2 squared to the power of x, yeah, to the power of 2x even, yeah. Now, again, because of laws of indices, we can expand that bracket there, yeah? So it becomes 2 to the power of 7x here, plus we times these together, so it becomes 2 to the power of 3x over 2 to the power of 4x here. Alright, now simplify. Using again laws of indices here, 2 to the power of 7x divided by 2 to the power of 4x is 2 to the power of 3x here. I know that because I just doing it. Alright, cool. 2 to the power of 3x here divided by 2 to the power of 4x again. So you're gonna take away the powers when you divide, yeah? So 3x minus 4x is minus x here. So therefore it's gonna be plus 2 to the power of minus x. Okay, cool. So now you need to differentiate that. Yeah, so that's the thing. So dy over dx here is equal to, again, so we keep it the same. Then you just put y here, yeah? Or fx. Okay, so again, keep it the same, yeah? So 2 to the power of 3x here. And then we do k ln a, yeah? So 3 ln 2, yeah? Easy, yeah? And then here we do the same thing. So we put 2 to the power of minus x, and then k ln ln 2, yeah? So k here is minus 1 technically, yeah? Because I got this negative sign. So I can put the negative there in front of the whole thing, yeah? So negative 1 ln 2, yeah? Ln of the base. Alright, question 3. Okay, question 3, it says find the gradient of the curve here. Y is equal to all of that at the point, whatever, yeah? So let's do that. So y is equal to e to the power of 2x here minus e to the power of minus 2x here squared. Again, you want to square the situation here. So again, we've got a squared plus 2ab plus b squared. A is this. So a squared is going to be e to the power of 2x squared, yeah? Which I think we can clock by now as e to the power of 4x. Yeah, I don't think I need to write every single time e to the power of 2x squared and then times it inside, yeah? Okay, cool. Safe. Now we do 2ab, yeah? This is a, this is b. Okay, nice. A times b, yeah? E to the power of 2x times e to the power of minus 2x. Remember, if you've got two things, so like x to the power of 2 times by, I'm going to use this dot as a times symbol, by the way, yeah? Times e to x to the power of 3, yeah? You add the powers, so 2 times 3 is 5, so it's x to the power of 5, yeah? So here we got 2x plus minus 2x, that's going to be 0, so it's just e to the power of 0. E to the power of 0 is just 1, because anything to the power of 0 is 1, yeah? So we got that times minus that is going to become minus 1, and then it's 2ab, yeah? So we need to times that by 2. So we're left with minus 2. Alright, cool. And then this squared here, because you're scoring a negative number, it's going to turn positive here. And this squared is going to be e to the power of minus 4x here. So we're timesing the minus 2x by 2 to square it here. Okay, cool. Alright, now differentiate. So bring the 4 down, and it stays the same inside the function. Minus 2 becomes nothing. And then bring the minus 4 down here. And then this function stays the same, so minus 4x here. So this is the differentiation. And now it's saying that x is equal to ln something. Let me check what it is. I think ln3. Yeah, alright, cool. ln3, yeah. So just put ln3 into here. So we get 4e, 4 times ln3, minus 4e, minus 4 times ln3. Okay. So if you put that into a calculator, yeah, apparently you'll get 26240 over 81. That's the final answer. So that's the gradient at that point, yeah. Okay, cool. Question 4. I'm gonna switch whiteboards soon. Okay. Y is equal to 2 to the power of x here, plus 2 to the power of minus x here. So now what we need to do is we need to just differentiate that. So dy over dx here is equal to, so here we keep the number there, so 2 to the power of x, and then we do ln of the base here, so ln 2, yeah. And obviously, here the number next to x is just 1, so k is 1, so it'll be 1 ln 2. There's no point in writing 1 here. Alright, cool. Here again, we write the same thing, so write the thing again, and then we're gonna do the k here is negative, so we're gonna do k ln 2. K is negative 1, so just negative 1 there, ln 2, yeah? So, no, and I think they want you to find the gradient when x is equal to 2 or some shit, yeah? At the point to find the tangent, yeah? Equation of tangent, so we need to find the gradient, and the gradient at the tangent is gonna be the same as the curve here. So the gradient here is gonna be x is equal to 2, because that's the x coordinate there. So you need to use that equivalently, yeah, in order to find it. So put that in here. So 2 to the power of 2, yeah, ln 2, minus 2 to the power of minus 2, ln 2. You need to actually, with these questions here, you need to get in a good habit here. You need to like stop relying on the calculator, because the calculator will give you like some decimal answer and they're not going to allow that. So what you need to do here sometimes is you need to like use logic here. So 2 squared is 4. So 4 ln 2 minus 2 to the power of minus 2 is 1 over 2 squared. So that's just 1 over 4. You could just put that in calculator, it'll be 1 over 4, yeah? And then ln 2 here, yeah? So now you use logic again. If I've got bases like this kind of situation, I've got 4 minus 1 over 4 here. That's just going to be 15 over 4 here. So I can combine this is like 4x minus 1 over 4x here. So it'll be 15 over 4x here. Or 15 over 4 ln 2, you guess. So that's what I mean by using like logic instead of a calculator, because you put that in a calculator, it might give you, it might work, I don't know, but it might also just give you some next decimal, yeah? Okay, let's go into this here. So y is equal to mx plus c, yeah? So mx plus c, we know what m is the gradient that we just found, so it's 15 over 4 ln 2 x plus c. And now obviously we can use the y coordinate and the x coordinate, yeah? The y coordinate, x coordinate at that point that we have here is 2 and 17 over 4, yeah? So 17 over 4 is the y coordinate, and 2 is the x coordinate. So 17 over 15 over 4 ln 2, and I've got x coordinate of 2, yeah? Plus c. So what I can do is I can times 15 over 4 by 2 straight away. So 17 over 4 is equal to, so 15 over 4 times 2 will become 15 over 2. And that's going to be, and then just ln 2. So that gets rid of this thing here, because that 2 times that, you get what I'm saying? Yeah, quick maths. Cool. And then obviously here, you just gotta move that whole thing to the other side, innit? Again, keep it as whole numbers here. So 17 over 4 minus 15 over 2 ln 2 is equal to c. Okay. Say no. Now, we can write y, we found c and we found m here. So y is equal to 15 over 4 ln 2, that's a gradient. X plus c. C is this whole thing here, so you can put in a bracket. So 17 over 4 minus 15 over 2 ln 2. Okay, nice. And now you just want to times the whole thing by 4, because we've got 4 here, 4 here, 4 here. 4 is the biggest number on the bottom, yeah? So times everything by 4, we get 4y is equal to 15 ln 2x plus 17 over 4 times 4 is going to become 17 again. So put in a bracket from here for c. So 17 here And then 15 over 2 times 4 is going to be 15 times 2, which is 30, yeah? And this is negative as well, so negative 30 ln 2. I think that's what they wanted to do. Let me just check. Yeah, I think that's it, yeah? So let me check if that's in the correct form. Yeah, cool, so that's just the equation tangent, yeah? Cleared up, yeah? That's the same as the mark scheme, yeah? Alright, so if question 5, you switch 5. Yeah, question 5, yeah? Nice. What are we saying here? Okay, so we got y is equal to e to the power of 2x here, minus ln x here. So differentiate that. E to the power of 2x differentiate, you bring the 2 down, and the inside stays the same, so it's 2x stays the same, and then ln x differentiates to 1 over x, so we got minus 1 over x here. Okay, cool, negative because it's negative up here, yeah? Nice. And now we want to make x equal to 1, it says here, to find the gradient. So we're going to be 2 to the power e to the power of 2 times 1, yeah? Minus 1 over 1. So obviously that's just going to get us 2e squared minus 1, yeah? Because that's 2e squared minus 1. Alright. So that's the gradient here. And here it doesn't tell us the y coordinate. And let me actually read the question now. We're trying to find an equation. Yeah, we're trying to find the equation with the tangent, yeah? So same gradient. And it doesn't tell us the y coordinate like the previous question, yes? We need to find the y coordinate, yeah? Y is equal to e to the power of 2x here, but we know that x is 1 at that point, so we can put 1 here, minus ln 1, yeah? And if you do that, yeah, ln 1 is just 0, so it's just e squared minus 0, which is just e squared, yeah? So we've got e squared is y, and we've got the gradient now. So this is a very easy question, actually. It's too bad. Nice little light one. So the gradient is 2e squared minus 1, that's what we found there, x plus c, yeah? And we know x and we know c, so and we know y. So y is equal to e squared, and then the gradient is gradient, yeah? X is equal to 1 and plus c. So now I can obviously easily find c. C is just going to be equal to, if I move that to that side, e squared minus 2e squared is minus e squared. And minus 1 to the other side is plus 1, yeah? And obviously 1 times that does nothing to it, yeah? Alright, cool. So that's the equation right there. So y is equal to 2e squared minus 1, that's the gradient, x plus minus e squared plus 1, which is c, yeah? And that's the form they want it in, innit? Yeah, that's the exact form that they want it in there. So that's the answer. No point in even writing 1 minus e squared. Alright, cool. Question 6. A particularly radioactive isotope, yeah, has some situations that's going on with it. Uh, Find the value of that one is that, yeah? Okay, so R is equal to, okay, so we're gonna say that's OCD in it. No, just a little bit, you know what I'm saying? Ah, so dr over dt, yeah, because obviously we're differentiating r in respect to t here, yeah? So obviously what we gotta do here is differentiate this situation. So 200 is gonna stay at the front anyway, because that's just a constant, yeah? It's like doing the 200 sine differentiate is 200 cos here. So 200 staying there. Now differentiate 0.9 to the power of t. So just write that 0.9 power of t again. That's how we do this. And then it's going to be ln base a, yeah? So ln the base is 0.9. So ln 0.9 there. Alright, nice and easy. Now what you want to do is it says find the rate, I think, when t is equal to 8, yeah? Is that the question? Yeah, find dr over dt when t is equal to 8. So you just put 8 into it, yeah? Very easy situation. Put 200, 0.9, power of 8, ln 0.9. You see that the rate's actually decreasing, it'll give you negative 9.07, yeah, that's the answer. Okay, cool. Question 7a. Population of that area in 900, 1900 was whatever, whatever, whatever. Alright, cool. Find the values of p, 0, and k, yeah? Okay. Well, listen, bro. When it started, yeah, the population of this town was 37,000, yeah? So that means that PO, the initial population, was 37,000, yeah? Come. Now P, yeah, which is at T 100 years, so 100 years later in 2000, yeah, the population was equal to 109,000, yeah, when T is equal to 100, yeah? I said this town, but it's Cambridge, by the way. Alright, cool. I'm saying it like it's some random, fuck off place or something. You get me? Alright, cool. Cool. So that's T equal 100, yeah. And obviously now we just substitute that into the equation. So it gives us the equation of P equals P 0 KT. So we know what P is. P is 109,000, yeah. And P0 is 37123. And then KT, yeah, and T is 100. So we can find K now easily, yeah. To find K, if you man don't know, you divide the 37,000 thing first, and that will give you 109 over 37, because obviously the zeros are going to cancel. And then now that's equal to k to the power of 100, yeah. And if you lot don't know, yeah, if you want to get like a base and you got a power, yeah, so let's say like 2 is equal to x to the power of 3, yeah. The way you do this is you apply the counter power to each side. So how do you cancel that 3? It would be by doing x to the power of 3 to the power of a third, yeah. If I put x to the power of 3 to the power of a third, 3 times a third will cancel, it will make 1. So it's just x to the power of 1. You get it? So the same thing here, so you got to do a third on that side too. So you just do the opposite here. So what you do here basically is you do 109 here over 37 to the power of 1 over 100 here. And that's going to give you just k alone, because it will be k to the power of 100 to the power of 1 over 100, which will cancel. So it's just k. You get it? So that's just a little trick here. Alright, cool. And then, yes, that's obviously just k is equal to 1.01 here, if you put that in your calculator. Alright, cool, let's do quick part B here. So now that we know that, we can fill in the equation, yeah? So P is equal to P0, which is 37k, and then k is equal to 1.01, yeah? Half T is a variable. Alright, safe. So let's find dp over dt now, because we need to do something. Yeah, evaluate dp over dt in the year 2000, yeah? So 2000 is 100 years later, so t is 100, yeah? So we'll just differentiate that. So dp over dt, yeah, is obviously equal to 37k stays at the front because that's just a constant. And then differentiate this thing here. Differentiate that, you just write it out again. So that's power of t. And then you do ln of the base, so ln of 1.01, yeah. And now t is equal to 100, yeah. So t equals 100. So then you're just going to put 100 into that, yeah. So it's going to be 37k 1.01 to the power of 100, yeah. ln of 1.01. Alright, so I can't lie, I cannot read that one. Listen, fam. I'm gonna make some assumptions here. Can't lie. I think that says here 10178. But you know what, yeah? We gotta go through these things together, innit? So we're gonna do this in live time. I wasn't got a note written down here that for T, for this ln situation, don't use 1.101 here. You're not gonna get the correct answer. They want you to use the full amount. So before I rounded it, it was 109 over 37 to the power of 1 over 100, yeah? So use that instead of 1.01. So instead of 1.01, yeah, use 109 over 37 to the power of 1 over 100 here. Alright, so let's do this calculation together then, yeah? So 37k 109 over 37, yeah? To the power of 1 over 100, yeah? Which is going to be power of 100 again, which is just going to cancel. And then Okay, listen here. You lot can dislike the video here. That's how these things go, man. You get me? Go check this live time. Okay, I've clocked it. I've clocked it. I've clocked it. I've clocked it. Okay, cool. So this is correct here. The only thing is that is not a zero in it. It's actually a one, yeah? This is what I'm saying. Yeah? You check it in live times, bro. You know it is, yeah. No editing, yeah. You just do it straight up, yeah. Alright. So that's actually 1178, yeah? It's because I scratched out the like something looked like a zero in it. That's why I put zero there. Alright, safe. So it's 1178, yeah. Alright, cool. Question C. What's it saying? What's he saying? Interpret your answers to part B in the context of the model, yeah. So obviously, whenever it talks about these kind of things, like differentiation on like a real life example, like dp or dt or whatever. So look at what you're doing. So it's dp of dt. That means that's the rate of population, yeah. So it's how quickly population is growing or decreasing. Yes, you're right. The rate of population, the rate of change, yeah. The rate of change. Use that terminology. In the year 2000, yeah, because that's the year that we evaluated that, yeah. So it means that in the year 2000, yeah, it's changing by this much per time, per unit time, yeah. Okay, cool. Question 8. It's like long exercise, you know. Okay, cool. Question 8 then. A student is attempting to differentiate ln kx here. Student writes whatever. Explain the mistake made by the student and state the correct derivative here. So the student here, yeah, he differentiated ln x here as if it's e to the power of x. Like he just took the k out, the constant, and kept it the same. Did you see that? So you need to write that. Obviously, the correct differentiation is 1 over x. Yeah? Okay, cool. Question 9. Prove that the derivative here of a to the power of k x is a to the power of k, and you may assume the derivative that is that. Yeah, okay, cool. So let's say so we need to prove that the derivative of that here is going to be the other thing here. So y is equal to the power of a to the power of kx here. We need to prove it's going to be k ln a, yeah. Okay, so I could write this here as e to the power of ln a kx. Why? Because e and ln will cancel to just give me a to the power of kx. You get it? Okay, understand that part. And technically speaking, because this is a power on the A, in terms of LA, I can bring that power down because of laws of logs here. So it becomes E power of KX ln A. Okay. Now I can rearrange this and I can take the X out of this in a way. So E to the power of K ln A X like that. Yeah. So you see how the left hand side, right hand side do the same thing. I put the X at the front, yeah. To make something clearer, yeah. Now we can differentiate this. And so to differentiate this here, remember, we're not using the assumption. We're not using the assumption. We're using the assumption of e to the power of x here. Because it's like an ex function. This is just a constant. KLNA is just a constant here. So it's like e to the power of 2x. It would be 2e to the power of 2x here. So we just bring this whole thing down. So KLNA e to the power of k ln ax here. Okay, now what you want to do is, what I can effectively do here is the opposite. We're undoing it now. I can bring x back in. So again, rearrange this here. to be k ln a, yeah? And now I can bring, instead of this here, I can bring x back in there, like back up front, yeah? So I can write kx here, ln a, kind of, yeah? You see why I'm doing this now? The reason I did that, yeah, is so that I can then use the log rule, yeah, of the power thing again to bring ka up here, kx up there, so it becomes ln a, the power of kx, yeah? Because if it's times at the front, you can bring up here like 3 ln 2 is equal to ln 2 to the power 3, yeah? Okay, cool. And now, obviously, what I can say now is that you get my man cancels with my man. So basically, what we just get is k ln a, and this whole thing gets pushed down. So just a to the power of kx, e and ln cancel, which is the same as a to the power of kx, k ln a. And so that's why we proved it. Yeah, save. Question 10. Okay. Question 10a, yeah. So we've got f of x is equal to e to the power of 2x here minus ln x squared plus 4 here. It's just asking to differentiate it, so f dash x, that's easy. E to the power of 2x, just 2 e to the power of 2x here, bring the 2 down, the top stays the same. Minus ln x squared here. I think we clocked by now again that this is going to be minus 2 over x, and then 4 just becomes nothing. This obviously is because of this here. I'll explain it one more time if you want. That's because that's equal to this. And differentiating that, that's just 2 over x here, because ln x is 1 over x, 2 times that is 2 over x here. Or just the power, whatever the power is here, like, times that down then. Alright, cool. So that's the situation there, yeah. Now let's do part B. Yeah, I'm gonna get greedy, I'm using another whiteboard in a minute too. Alright, the curve of the equation that has a gradient of 2 at point P. The x-coordinate of P is A. Show that that is equal to that. Okay, so the gradient is 2 at point P. So 2 is equal to this thing. This is the gradient here. This is the dy over dx here. So 2 e to the power of 2x minus 2 over x here. I see. So obviously it says that x is actually equal to A. So I can actually get rid of this x and I can write A here. Okay. Now it's just simple rearranging, bro. Times everything by A. I get 2a to clear the fraction. 2a e to the power of 2a. Again, I forgot to change the a there. That's x is a here. Minus 2, because it says that x is a in the question. Okay, now I can obviously, bro, it's big. Divide everything by 2. So a is equal to a e to a minus 1 here. Okay. And now obviously bring the 1 to that side and bring a to that side. So add the 1 on both sides and take away a from the left hand side. That's a e to a minus a here. This is because I'm trying to get in the form that they want, yeah. So that situation there. And now obviously factorize a outside. So factorize a like that. E squared minus 1. A squared divided by a is just e squared. And then minus a divided by a is minus 1. And now, is that not literally the situation that they want? Yeah, it is. They y is equal to 5 sine 3x plus 2 cos 3x here. Okay. What does it want me to do, fam? It just wants me to show that the point that lies on that here. So just basically put the point here. So x is equal to 0, and then it should give us a y coordinate of 2. So x is equal to 0, put 0 into there. That's 5 sine 3 times 0, which is just 0, plus 2 cos 3 times 0, which is 0. Obviously, that's going to give you 2. For your calculator. So therefore, so you're right. So 0, 2 lies on the curve here. Okay. Part B here. Part B is saying find dy over dx. So dy over dx here. Differentiate. So the original thing was 5 sine 3x plus 2 cos 3x here. So 5 sine 3 times 5 is 15 here. Sine differentiate this cos 3x remains inside the same. So there we go there. And then 3 times 2. Cost differentiate is a minus sign. 3 times 2 is 6, so that's minus 6 sign. And the inside is the same, so it's 3. Alright, save. And once you find the gradient, find the gradient of the normal to the curve. That's long, bro. So you need to find the gradient and do negative reciprocal, yeah. So the gradient at P, yeah, P is exponent is 0, so 15 cos 0 minus 6 sine 0. That's going to give you 1, it's going to give you 15 here. So therefore the gradient is going to be negative reciprocal because it's normal, so perpendicular, so negative 1 over 15 here. And now you just want to do y is equal to negative 1 over 15x plus c. We know what x is, we know what c is, nice and easy. Y is, we know that y is 2, we know that x is 0, so minus 15, 0 plus c, so obviously c is equal to 2. Nice and simple, yeah, that's what I like, bro, that's what I like to see. And obviously that's 2 is equal to c, so therefore y is equal to minus 1 over 15x plus 2, yeah. Okay, save. Question 12. There's no parts of question 12 as well, but it's a bit long. Alright, cool. So we got y is equal to 2, 3 to the power 4x here. We need to differentiate that, so dy over dx here is equal to, it's a bit of a long one here. So obviously, differentiating this here, we just write the same thing, so 3 to the power 4x. And then k ln a, yeah, so k is 4. So it'll be like 4 ln 3, yeah, which is the base. But because we had that 2 originally, 2 times 4 is going to make 8. So that's the differentiated version is 8 here, yeah. Okay, save. So now that we got that, we need to find the gradient when x is 1. So at that point, so x is equal to 1, yeah. Again, I think we've got another normal here, so perpendicular. So x is equal to 1, so we put 8, 3 to the power 4 times 1, yeah. Ln 3. And that's equal to 648 ln 3 apparently. Okay. We also need to find the y coordinate. It didn't give us that because, you know, they didn't give us that because they're pricks. So you need to put 3 to the power 4 times 1 here. And obviously that's going to get you the y coordinate here, which is apparently 162. Yeah, that's what I like to see. Okay, so 162 is y, x is 1. And we've got a gradient now, which is that. But we need to do negative reciprocal. So m is equal to 1 over that, yeah? So 1 over 648 ln 3, yeah? And because negative reciprocal, we need to put negative as well. Okay. Nice. So y therefore is equal to mx plus c. M is minus 1 over 648 ln 3 plus c, x plus c. And now we just need to put in the numbers in it. So y is obviously 162 minus 1 over 648 ln 3. And then x is obviously 1, yeah, plus c. And because of that, you'll see that c, therefore, is just equal to bring this whole thing on the left, 162 plus 1 over 648 ln 3. So therefore, you know, some of you might have made the observation here that we're actually finished with this question because we can just write now y is equal to the gradient here, which is 1 over 648 ln 3 x plus 162 plus 1 over 648, which is this is c here, ln 3. That's the whole situation though. You say you're my brother, then don't change on me. For you, I risk it all like I got nothing to lose. I just hope that you will do the same for me. She say we the realest, I say baby it's true. You say you're my brother, then don't change on me.